Hello and welcome to a video on the properties of rhombi. Now rhombi is just plural for rhombus. So when you have more than one rhombus, you have many rhombi. Okay, so it's kind of like octopi and hippopotami. Alright, so first of all, every rhombus is a parallelogram. So because every rhombus is a parallelogram, they have all of the properties of parallelograms. So we really want to be familiar with all 5 of those properties, including the second one, which is really the definition of a parallelogram, but it's still a property. It's still something that if you know you have a parallelogram, you know you have 2 pairs of opposite sides that are parallel. Now, the first thing I want to do is actually contrast what a rhombus looks like as a specific parallelogram. Now, in the top figure here, you're looking at a rhombus, meaning that all 4 sides are congruent. That's the definition of a rhombus. So that's not the case for parallelograms, right? In a parallelogram, you have one pair of sides that are parallel and another pair of sides that are different. I mean congruent, and they're different but congruent. Now, it doesn't mean that it's a parallelogram. It doesn't mean that they can't be the same. And when they are the same, that's a rhombus. Okay, so this is the rhombus up on top. And I want you to notice 2 things about the diagonals. That's true in the special case of a rhombus, but not true in a parallelogram. So this is a rhombus, and of course, it's still a parallelogram. And on the bottom, this is not a rhombus, right? Of course, it is a parallelogram, but it's not a rhombus. So if you have a parallelogram that's not a rhombus, take a look at how the 2 diagonals intersect. You're looking at an angle here and here. Of course, they're vertical angles, so of course they're equal. But then you're looking at what looks like very different angles here and here. So the 2 pairs of angles in a general parallelogram that's not a rhombus are not at all equal, and they're certainly not right angles. When you make all 4 sides the same, then that does change inside here. In the very middle here, you will always have what it looks like. It looks like a right angle, and in fact, anytime you have a rhombus, the diagonals are perpendicular to each other. All right, and then the other thing I want you to look at is I want you to look at the way that the diagonals intersect the angles. So, for example, we know that these 2 angles, let's put 3 marks here. These 2 angles are alternate interior angles, right? We know that because it's a parallelogram. But these angles here, I'm going to put 4 marks here. These are also alternate interior angles, but they're not the same, right? So angle 1 and angle 2, we would say here that the measure of angle 1 does not equal the measure of angle 2. All right? So it wouldn't make sense to say, for example, that the diagonal bisects that angle because those 2 are not equal. Now look at the rhombus. And you can see it looks like they are, and they actually are bisected. So in this case, not only are, let's do these 2. These angles here, not only are they alternate interior angles, and these are also alternate interior angles, but all 4 of those angles in the case of the rhombus are equal, which is telling us that the diagonal actually is bisecting that angle of the rhombus. And the same thing is true here. These are different angles, but all 4 of these are equal. And that's going to make it kind of easy to find angles in rhombi because you have these congruences that you don't have in general parallelograms. All right, let's take a look at the properties now in writing. So pretty much going to write down what we just said. So we already have the properties of parallelograms are already there, and they're still going to be there for all rhombi. But we also know that the definition of a rhombus is all 4 sides are congruent. All right, and we notice that the diagonals are perpendicular. And last, we notice that the diagonals bisect the angles of the rhombus. All right, so keeping those things in mind, and you probably want to have this So draw it out so you can see the angles that are equal here and the perpendicular angles. And this is what we're going to see for all rhombi. All right, so let's look at our first example. The first example has nothing to do with angles. Actually, the first two examples don't really involve angles, except knowing that the diagonals are perpendicular. So you might have some right triangles here. So let's take a look at what's given for example 1 here. We're given that JK is 12. So let's just write that in here. JK is 12. And we're given that JN is 7. So JN, this one right here, is 7. Now, before we go ahead and answer the questions to the right, let's just think about this. This is a rhombus. So if JK is 12, everything is 12. So these are all 12s. All right, and the diagonals, they're not the same length, but these two are definitely going to be the same. So this is going to be 7 here, these two half diagonals. It's still bisected because it's still a parallelogram. Now, we also know that this is a right angle. So how can we use that to find this length right here? Well, we can notice that this length here, NK, is part of a right triangle. So we can use Pythagorean theorem. Now, right across from the right angle, that's going to be our hypotenuse. So we can write 12 squared is equal to 7 squared plus, and that's for a moment, let's just call this x. X squared. All right, 144 is equal to 49 plus x squared. 144 minus 49 is 95 is equal to x squared. So we now know that x is equal to the square root of 95. All right, so this is rad 95. Now let's go ahead and answer the questions on the right. So JM we did not, let's see, JM we wrote down as 12, so let's just put that in here. JL is the entire diagonal, so that has to be 14. 7 plus 7. MN is the same thing as what we just found, NK. So MN and NK, these are both the square root of 95, right? So we can write that in here for MN. That's the only one that really took a little bit of work. And then MK is twice that square root of 95, so it's 2 rad 95. Now, I'm not really going to be picky about whether or not you write this as a decimal and you put this in the calculator, but that's the exact answer. Okay, let's look at the next example. So this is very similar, so why don't I'm going to pause the video and see if you can fill everything out. You will need Pythagorean theorem here, so give it a shot. All right, so there we have our answers. In the process, we needed a right triangle, and this time we were given the hypotenuse, while the last example we were looking for the hypotenuse. Oh, no, I take that back. We were given the hypotenuse in both of these examples. All right. Now, one thing, just a little bit of a detail I did throw in the approximation on this. So when we found GH, square root of 129, I put that in the calculator, and I found 11.4. Now, if you look at GE, which is the whole diagonal, notice that that's not twice 11.4. Well, I'm just choosing to be more accurate, and instead of rounding from my calculator, the calculator doesn't really say 11.4. It says 11.3578, and when you double that, that's approximately 22.7. One of the reasons that I want to just sort of, I'm leaning towards suggesting that you just ignore the decimals, even though, students generally like decimals more than radicals, but there is a complication that's added when you have radicals. It's very easy to be off by a tenth. All right, let's look at the next example. All right, so here, another one that's the same. So we're going to do the same thing. I'm going to pause the video and see if you guys, because this is not about angles yet. It's very similar. So give it a try. Okay, so on this one, notice that this time we were not given the hypotenuse. We were given the full diagonals, RT and US, and we started out by remembering that this is still a parallelogram, so the diagonals bisect each other. So I wrote the 9 and 9 and the 11 and 11, and then from there you can see that we were looking for, this started out as x, right? It started out as this x right here. That's the hypotenuse of the right triangle. So let me just highlight the right triangle that I use. They're all the same in a rhombus. All 4 triangles are the same. All right, and there we go. This time we didn't have an issue with doubling our half diagonal because we're just finding the side of the parallelogram. Of the rhombus. All right, let's look at an example with angles. Now, the beautiful thing about angles is once you know one angle in a rhombus, you know all of the angles in the rhombus. All right, so let's see how that can be. So first of all, we know the diagonals bisect the angles. So this is 38 here. And both sides of these are the same. So all of these are all 38. Now, to move forward from there, we really have to get a right triangle. So we have to focus on any one of these right triangles. I'm just going to focus on, it doesn't matter, the one on the bottom. Okay, so this triangle down here, it is a rhombus, so this is a right triangle. And we have some angles in here, and we know that the angles, these are all angles, none of them are sides. We know that the three angles of a triangle add up to 180, so if we add the 90 and the 38, and we get 128, and then we subtract that from 180, we're just doing what we've been doing for a while, finding the third angle in a triangle. So this is 52. So here is 52, and these are all 52. And there we go. Now we should be able to pretty much answer any question here. So angle 1 is 52. Angle 2 is also 52. Oops. Angle 3 is 38. Angle 4, where is angle 4? There it is. It's also 38. Angle 5 is 38. Angle 6 is 52. Angle 7 is 52. And angle 8 is in the middle. That's a right angle, so that's 90. Okay, and the last one is a great one to try on your own. This one, the only difference is it has both of what we've been doing so far. So it has angles and sides. So I'm going to have you pause the video and we're going to do the angles first. Let's just focus on the angles first, and then we'll compare, and then we'll fill in those answers. Then we'll look at the sides because it gets a little busy if we try to fill in everything in this diagram. So we're going to look at just the angles. Okay, there's all of the angles. Remember that these are always congruent triangles within a rhombus. All four of these triangles are congruent. And you can see there's just 36, there's 34, 56, and 90s, and that's all of the angles that there are. Okay, so we can fill those in on the right. Okay, so there's the four angles that were asked for. And now I'm going to pause the video again, and this time we're going to focus 100% on the sides, which is going to be like the first three examples, really. Okay, so let's try finding all the sides, put them in the triangles and into the rhombus, and then see if you can find all of the sides there. Okay, so here's the rhombus with every side filled in. Notice that this time it was like examples 1 and 2 where we were given the hypotenuse. Notice that we're always given one of the sides, like this one here, and then we're always given, it seems like we're usually given the entire diagonal, and we have to remember to divide it by 2. That's where the 2 19s came from. And usually you will have to use Pythagorean theorem when you have right triangles, and that's what we did here. And there's our values. Okay, so let's plug them into the answers. Okay, there's the third example. So remember, most important thing is every rhombus is also a parallelogram, so it has all 5 of those properties. It's a rhombus, so all 3 sides are equal. That means that the diagonals will will be perpendicular to each other and also bisect the angles of the rhombus. And very quickly here, just to note, if you look at what we know about a rhombus, we can see why there's 4 congruent triangles. They all have the same, and we can just choose here angle, side, angle. They all have the same angle, side, angle. So by that, all 4 triangles are congruent. Really important to kind of keep that in mind. If you forget the rules, you remember this about a rhombus. All 4 triangles are congruent. And sometimes that can save you. Okay, I hope you found this video helpful.